Here's problem 34. A 2 centimeter length of wire centered on the origin carries a 20 amp current directed in the positive y direction. Determine the magnetic field at a point x equal 5 meters on the x-axis. Alright, let's imagine what's going on here. We have a wire located between a -1 and 1 centimeters on the y-axis, because it's a 2 centimeter length of wire. So there's our wire right there, centimeters, and it's carrying it from -1 to 1, so it's carrying it upwards like this. And we want to find the magnetic field at a point x equal 5 meters on the x-axis. So that's really far away compared to centimeters. We have 5 meters. And so that's our point way over here. According to the right-hand rule, if I point my thumb in the direction of this current along the y-axis, my fingers will be curling into the page at point P. So our magnetic field is going to be into the page at this point. Alright, so we are interested in what this magnetic field is at point P. Alright, based on Biot-Savart law, the magnetic field at P should be equal to mu naught I over 4 pi r cosine theta 1 minus cosine theta 2. Alright, in this case, mu naught is 4 pi times 10 to the minus 7. Our current is 20 amps. Our distance r is the perpendicular distance to the line of action of this current. The line of action of this current is the y-axis, and the shortest distance to that line is this distance right here to point P, which is 5 meters. So our r is 5 meters. Cosine theta 1. Now theta 1 is this angle right here. And the cosine of that angle would be the adjacent side over the hypotenuse. For all practical purposes, the hypotenuse is also going to be 5 meters long. And you can figure it out if you wish, but employ the Pythagorean theorem, but it definitely will come out to, within error, 5 meters. So this cosine theta 1 will be the adjacent side over the hypotenuse, which would be 0.01 meters over 5 meters. Minus the cosine of theta 2. Now theta 2 is this angle right here, which is the supplementary angle of the internal angle here, which is the same angle as theta 1. So theta 2, the cosine of theta 2 is going to be a negative 0.01 over 5, because it will be the negative cosine of theta 1. Okay. So now we have 4 pi's canceling out here, and so this is equal to 2 times 10 to the minus 6 over 5 times 2 centimeters over 5. So we will have, if we calculate all that out, 2 times 10 to the minus 6 times 0.02 divided by 25, 1.6 times 10 to the minus 9 Tesla. And that would be into the page. We could say it's 1.6 nanotesla if we wish. 1.6 nanotesla into the page. So that's our answer.